Welcome back to our beads. So before we're going to be starting to estimate the proportion of pink beads in this bucket of beads, okay, we first want to figure out what do we know about this distribution, okay? So we pretend to ourselves that this cup that we took of the beads from the bucket, that it was, first of all, we want to make sure that this was actually an SRS. It was a simple random sample. Now, if you remember, we got 15 pink beads in there, and we had 148 all total beads in there. And this altogether sort of gave us this, so let's really quickly write there that we had pink beads, we had 15 of them, and I'm gonna put here non-pink, okay? We had 133, and total beads that we had in that little sample of a cup. This is a different cup, but if I took lots of them, I would have 148 beads in a cup, okay? So if the sample size is large enough, is it large enough? Is it only 5 beads? No, it's 148 beads. If the sample size is large enough, and now this is kind of important, that the NP and NQ are both more than 10, okay? So let's really quickly look at this. So what was the proportion of my successful beads? I would actually go and do 15 out of 148. So actually, I know what was my proportion here. It was more than 10 because I had here 15 beads. I also know that the proportion, this is actually hats. I also know that that the number of failures, not pink beads, was also more than 10. Okay, so since both of those conditions are satisfied, I can go ahead and actually start talking about the sampling distribution of my sample proportion of my cup of beads. All right, and by the way, my P hat for that particular cup of beads that we did, 15 out of 148, is actually going to be 0.101. Okay, which leaves me with Q hat to be the complement of this, to be 1 minus. So this is going to be 0.899. Okay, and again, if I were to multiply this by 148, I would get, I would almost get 15, and if I were to multiply this by this, I would get almost 133. You can go ahead and try this on your own. So in order to figure out how my sampling distribution of P hat looks like, I would like to know 2 things about that sampling distribution. And what are those 2 things? I would like to know the mean of P hat, and I also would like to know the standard deviation of P hat. Well, the beauty of my sample, the beauty of these beads is that, and not just beads, whenever we want to go and estimate proportion, is that we're actually going to, the mean is going to be the mean of the population. Okay, the proportion of things in the population. So one sample is going to be a little bit below, one sample is going to be a little bit above, but they're all going to be somewhere where the true population proportion is. Now, as far as the standard deviation goes, well, the standard deviation is actually going to be PQ over N inside a square root. Well, in practice, we do not know the value of P. If we did, we would not need to construct a confidence interval for it, okay? In large samples, P hat is close enough to P. So is this a large sample? You can argue that anything over 30 will be a large sample. So in large samples, we are going to use P hat. We're going to replace our P with P hat. So instead of P, I'm going to use here my P hat. Instead of Q, I'm going to use my Q hat. So what would be the standard deviation of of what I have here, well, I am just going to take these and divide them by 148. Would be nicer if I had 150 beads, but I just took a random sample of beads, and this is what I got there, and one got away. So, so I have here 0.101 times 0.899 divided by 148. Okay, and if we're going to do the math, we're going to end up with this being 0.0247. Okay, that's the standard deviation of my population proportion. Okay, of my, I'm sorry, take it back, sampling proportion. And what was my mean? Well, my mean is going to be, we are going to use my p hat for my mean, and we're going to use here my 0.0101. Okay, and in the next slide, we are going to go and estimate our interval, okay, and see what we get there.